Hello, welcome to today's video. Our goal for today is to learn how to convert units. This will include both imperial and metric units. Our evidence for today is as follows. First, we will learn some of the common units of measurement. We are then going to find rates to help us convert measurements. Finally, we will practice converting units. You can read our learning experience here. I hope you enjoy our video, and let's switch into our first set of measurements.
So let's start with our imperial conversion rates. Pause the video right now and write this down. I'm going to talk about some of the details here as well. So imperial conversion rates, you might also hear these as customary conversion rates or customary units. I personally think imperial sounds cooler, so that's what we're going to go with. We got three main ways of measuring with imperial units. We've got length, capacity, and weight. Here is what you're probably most familiar with. 12 inches is equal to a foot. 1 yard is equal to 36 inches. That also means that 1 yard would equal 3 feet. 1 mile would be 5,280 feet. If you live in Denver, you probably know that number. In this one, 1 mile is equal to 1,760 yards. I've never heard anybody actually use in real life, but it's possible that on a math problem you might see that, possibly. Then we've got capacity. Capacity is like thinking about volume. So we got 3 teaspoons is equal to a tablespoon. 2 tablespoons is equal to 1 fluid ounce. 8 fluid ounces is equal to 1 cup. 2 cups is a pint. 2 pints is a quart. And 4 quarts is a gallon. Gallon is the biggest volume that we're going to be using here. And yeah. Weight is a lot shorter, which is kind of nice. We got 16 ounces to 1 pound, and there are 2,000 pounds in 1 ton. So nothing too bad there. I'm going to move on and start talking about how you use these. So again, if you need to finish writing anything down, pause the video now. So how do we actually use these? Well, let's use an example. We got Gyarados here. Gyarados is officially measured at 21 feet and 4 inches. We want to find its length in just inches. So we've actually got to do 2 steps here. Not every problem you're going to need to do this, but sometimes you will. Let's start with our 21 feet. Okay? We know from our table previously that there should be in 1 foot 12 inches. Since, of course, we've been working with rates and ratios, we can also write this as either 1 foot over 12 inches or 12 inches over 1 foot, depending on how you would prefer. Now, this actually does matter because we are trying to find the length in inches. So what we're going to do is we're going to put a little multiplication sign here, and we're going to put it in our line for our fraction, but we're not going to fill it in yet. We're then going to put our equal sign. We're just going to leave a space for it to be blank, and then we're going to put the units that we want to get. We want to get inches, so we're going to put inches here. Now, as for which ratio we use, which rate we use, we want to use the one that's got the units that we want to get on top. So since we want to get inches, we have to use the one where inches is featured on top of our fraction. So we'll write this here, 12 inches over 1 foot, and then we just have to do some multiplication. So 21 times 12, I don't know what that is off the top of my head, so I'm going to have to do it the long way. 2 times 1 is 2, 2 times 2 is 4, 0, 1 times 1 is 1, times 2. We add these, and we end up writing it weirdly and sideways. We get 252 inches. Now, the important thing to remember here in this specific example is that we know that Gyarados also has an additional 4 inches. So we actually have to add 4 to that. And then we'll get an actual solution of 256 inches. It's really, really important, though, that you make sure that you have your rates set up the correct direction. If you want to know why that matters, think about how things would make a giant 1. We have feet here. If we divide feet by feet, we just get a 1, so it just leaves us with inches. Pause the video if you need to write any of this down, and then we're going to go on to our first you-do. Our first you-do problem, very similar to the previous one, but this time you are going to find the length of a Rayquaza in yards. You know that it's 23 feet long. How long is it going to be in yards? Pause the video, give this a try. You're not necessarily going to end up with a whole number. Let's talk about metric units. Now, metric units you probably, if you live in the US at least, don't use on a regular basis. Unless you're in anything scientific. If you're in anything scientific, then you are going to use metric all of the time. So before I continue talking about metric, pause the video, copy down these tables. This one might take you a little bit longer, so remember, just pause the video, write them down. So, let's talk about the 3 types of measurements. We have length, capacity, and weight again. However, this time, we use different words for each one. And you're probably familiar with each one. But in case you're not, we'll go through them. So for length, the base unit that we use is a meter. With capacity, we use a liter. And with weight, we use grams. Everything in metric is based off of one of those things. So for example, a millimeter, which is a very, very small measurement, you'd have 1,000 millimeters in 1 meter. You'd have 100 centimeters in 1 meter, 10 decimeters in 1 meter. You have 1 decameter made out of 10 meters, 1 hectometer in 100 meters, and 1 kilometer in 1,000 meters. And if you look through the other tables, you'll notice that they all match, other than the fact that it says grams or liters. Let's pretend that says that's an L. But other than that, it's the same thing. And each time you go up 1, all you're doing is multiplying this by 10. And then we multiply by 10 here, times 10, times 10. That also means that when we are converting things in metric, let's say that we have something that's 4 meters in length. If we were want to change this to decimeters, all we would need to do is move the decimal point over. Using a base of 10 makes things really, really easy. So let's again talk about Gyarados in this example. We know that Gyarados weighs 230 kilograms. That's quite a bit. We are going to find the mass in grams. So because kilo means 1,000, we know that there are going to be 1,000 grams in 1 kilogram. So already we have our conversion rate there. We can write it as a rate. We don't know necessarily which one we're going to use yet, so we could write both, though if you read the problem, you can probably figure it out. We have kilograms. We want to get grams, so that means the 1,000 is going to go on top, and the 1 kilogram is going to go on the bottom. So again, this just means that we're multiplying. We multiply 235 times 1,000. The nice thing is, since it's a multiple of 10, it makes it really easy to multiply. We just add the 3 zeros, and we get 235,000 grams. That's a lot. Again, you could have, if you're clever, realize that since this is in kilograms and we want grams, move it over 1, 2, 3 times, the decimal that is, and we would get the exact same value. We, of course, need to include our units, but that's pretty much it. There's a reason that most mathematicians and engineers and scientists use the metric system. It's a lot easier. And also, most of the rest of the world uses it. I think there are like 4 or 5 countries that use the customary / imperial system. And for some reason, the US is one of them. Anyway, politics aside, copy this down if you need, and then we'll move on to our you-do. Your second you-do for today, you have Whitney, who drinks 83 centiliters of moo-moo milk. If a bottle of moo-moo milk contains 1 liter, how much milk would be left? So you're not just doing a unit conversion, but you're also trying to do one other thing. I'm going to let you think about what that last thing should be, but start with finding how many liters she drank. Give that a shot. Pause the video if you need. Ready to go.
Here are a few things to remember from today's video. Firstly, remember that unit conversions are different depending on the system you use. It will depend on if you use metric or imperial units. When using a unit conversion rate, always put the value you want on top and the value you have on the bottom. This will help make sure you get the answer you actually want. Finally, the only operations you will need is either multiplication or division depending on the problem. We have one last thing for you in this video. Please take a look.
This wouldn't be a complete math video without some suggested practice problems. Here you have 6 different conversion problems. You are going to need to use the tables that you copied down earlier to help you with these. The first 3 are all customary / imperial units. The bottom 3 are all metric units. I'm curious to see which one you think is easier based on what we learned. Good luck.